Welcome to Astronomy Daily, your go-to podcast for the latest and greatest in space and astronomy news. I'm Anna.
And I'm Avery. We're so glad you could join us today as we dive into some truly fascinating developments from across the cosmos and right here on Earth.
That's right, Avery. Today we're going to be talking about NASA's ambitious plans for a nuclear reactor on the moon, a surprising new study that redates Earth's oldest impact crater, and a breakthrough discovery of a potentially habitable super-Earth.
We'll also cover the crucial sunshield installation on the Nancy Grace Roman Space Telescope, preparing it to give us an unprecedented look into the infrared universe. So buckle up, because we've got a lot of exciting news to discuss. Let's get started.
First up, let's talk about NASA's incredibly ambitious plans to power our future lunar outposts. It seems the agency is really kicking things into high gear when it comes to getting a nuclear reactor on the moon.
That's right, Anna. For a few years now, NASA has been working on a 40-kilowatt fission system aiming for a launch by the early 2030s. But now, Interim NASA Chief Sean Duffy is pushing for an even more aggressive timeline and a more powerful system.
That's a significant jump. Politico reported that Duffy's new directive, which was set to be released recently, orders the agency to solicit industry proposals for a massive 100-kilowatt nuclear reactor to launch by 2030. This is seen as a critical step for the Artemis program, which aims to return astronauts to the lunar surface and establish permanent bases there around the same time.
And nuclear power is truly essential for that vision. Solar energy simply isn't a great option for a crewed outpost because the moon rotates so slowly. A lunar night can last about 2 Earth weeks, which means no sunlight for an extended period. Nuclear power provides consistent, reliable energy regardless of day or night.
It's not just about practicality, though. There's a strong strategic element at play here. China also has plans to set up a moon base, partnering with Russia and other nations. Duffy's directive is very much geared towards beating China to the punch.
The directive even highlights the geopolitical implications, stating that the first nation with a moon reactor could declare a keep-out zone, which would significantly inhibit other nations, including the United States. It's clear that the race for lunar resources and presence is heating up.
Absolutely. This really underscores the importance of reliable, long-term power sources for establishing a sustainable human presence beyond Earth and the strategic advantages that come with it. It's a fascinating blend of science, engineering, and international relations.
Moving from the moon to our own planet, there's a fascinating new development about Earth's oldest known impact crater. It turns out our geological clocks sometimes need a recalibration, and that's exactly what happened with the Moralaga impact structure in Western Australia.
That's right. This site in the remote Pilbara region made headlines previously, with a different group claiming it was Earth's oldest impact crater, formed about 3.5 billion years ago, and incredibly over 100 kilometers in diameter. If true, that would have been a game changer for understanding early Earth.
But as it turns out, new research published in Science Advances tells a different story. While they agree it was an ancient meteorite impact, this new study concludes the impact actually happened much later, sometime after 2.7 billion years ago, and possibly even more recently. That's at least 800 million years younger than the earlier estimate.
And the size estimate is drastically different, too. The new study determined the crater was much smaller, only about 16 kilometers in diameter, a far cry from the original 100-plus kilometers. This means it was too young and too small to have influenced continent formation or early life, as was previously speculated.
So how could two studies investigating the same site come to such different conclusions? Both groups found telltale signs of meteorite impact, shatter cones. These are unique conical imprints of shock waves that pass through rocks, and their presence confirms it's an impact site. The disagreement came down to dating.
They both used a geological principle called the law of superposition, which states that younger rock layers are deposited on top of older ones. The first group found shatter cones within and below a sedimentary layer known to be 3.47 billion years old, but not in younger rocks above it, suggesting the impact happened during that 3.47 billion year period.
However, the newer investigation found Saturn cones not only in those same 3.47 billion-year-old rocks, but also in younger overlying rocks, including lavas that erupted 2.77 billion years ago. This crucial detail meant the impact had to occur after the formation of the youngest rocks containing shatter cones, placing it sometime after 2.77 billion years ago. The precise younger age is still being worked on with isotopic methods.
It's a fantastic example of how science is a self-policing sport. Initial claims are based on available data, but new observations can modify or even overturn them. While Moralaga isn't Earth's oldest crater anymore, it's still scientifically unique because craters formed in basalt are quite rare. The basalts there are the oldest shocked target rocks known.
And here's where it gets even more interesting. Prior to the impact, these ancient basalts were chemically altered by seawater, and nearby sedimentary rocks contain some of Earth's earliest well-established fossils. These kinds of rocks likely covered much of early Earth and even early Mars.
This makes the Moralaga impact structure a fantastic outdoor laboratory for planetary scientists. It's an easily accessible proving ground for instruments and imagery intended for Mars exploration, helping us understand the cratered surface and perhaps even early life on the red planet, all without leaving Earth.
From ancient Earth, let's turn our gaze outwards to a truly exciting breakthrough in the search for life beyond our planet. A new detection method has just revealed a potentially habitable super-Earth.
This is huge. The enduring question of are we alone has driven astronomy for generations, and discoveries like this bring us closer to an answer. Since the first exoplanet orbiting a sun-like star was found in 1995, the hunt for Earth-like conditions in habitable zones has been a primary focus.
And this latest discovery is significant. An international team, led by the Yunnan observatories of the Chinese Academy of Sciences, has made a major breakthrough using a method called transit timing variation, or TTV.
For the very first time, TTV enabled the detection of a super-Earth named Kepler 725c. It's truly a monumental find because this planet is about 10 times the mass of Earth and orbits within the habitable zone of its sun-like star, Kepler 725. Their findings were just published in Nature Astronomy.
Additionally, astronomers have relied on the transit method or radial velocity measurements to detect low-mass planets, those 10 Earth masses or less, especially in habitable zones. But these smaller planets usually have long orbits and produce very weak radial velocity signals, making them incredibly difficult to spot.
The transit method also has its challenges. It only works if the planet's orbit aligns perfectly with our line of sight, which is uncommon for planets with long orbital periods. Even if they do align, the light changes can be too dim and brief to be confidently identified, meaning many potential discoveries are missed.
This is where TTV comes in as a game changer. Kepler 725c is a non-transiting planet, meaning it doesn't pass directly in front of its star from our perspective. The team successfully inferred its mass and orbital parameters by analyzing the TTV signals of Kepler 725b, a gas giant in the same system that does transit.
Kepler 725c orbits a G9V host star with a period of 207.5 days. It receives roughly 1.4 times the solar radiation that Earth does, placing it within the host star's habitable zone for part of its orbit, which definitely makes it a strong candidate for habitability.
What's so revolutionary about the TTV technique is that it doesn't require an dead-on orbit or rely on those super high-precision radial velocity measurements. This makes it uniquely suited for detecting those small, long-period, non-transiting habitable planets that are otherwise extremely difficult to discover.
It fills a critical gap in our current exoplanet detection methods. Based on this study, missions like the European Plato and Chinese ET, or Earth 2.0 missions, once operational, are expected to greatly enhance our ability to detect a second Earth. It's a huge leap forward in the search for another habitable world.
Speaking of advanced technology pushing the boundaries of discovery, let's talk about the Nancy Grace Roman Space Telescope. Technicians at NASA Goddard Space Flight Center have been busy installing crucial components like the solar array sunshield.
That's right. This shield, made up of 6 panels covered in solar cells, is essential. It's designed to provide the observatory with power, while simultaneously keeping its sensitive instruments cool throughout its mission. This marked a major milestone, completing the telescope's outer section.
And just recently, NASA announced they finished installing the 2 panels of the lower instrument sunshade on Roman's inner segment. Along with the solar array sunshield and the deployable aperture cover, which is essentially its visor, these shields are absolutely critical for Roman's mission to explore the infrared universe.
It's very similar to Webb's sunshield. Roman's sunshades and aperture cover will protect its instruments from the heat and light from the sun, which would otherwise interfere with its ability to detect those incredibly faint signals from deep space.
Conrad Mason, an aerospace engineer at NASA Goddard, described them as basically giant aluminum sandwiches. They're made with metal sheets as thin as a credit card on the top and bottom, with the honeycomb structure in the middle. This design makes them stiff yet lightweight, and specialized polymer film blankets help temper heat transfer from the sun-facing side to the back.
Matthew Stevens, another aerospace engineer at NASA Goddard, perfectly summed it up, saying, "This shield is like an extremely strong sunblock for Roman's sensitive instruments." He also mentioned that the deploying mechanisms have dampers, similar to soft close hinges, so the panels won't slam open. They take about 2 minutes to move into their final positions, and this will be the very first system Roman deploys in space after launch.
With the inner segment fully assembled, it's now undergoing a 70-day thermal vacuum test to ensure full functionality under simulated space conditions. After that, the inner and outer segments will be integrated by November, with a launch expected between fall 2026 and May 2027.
The Roman Space Telescope, named after Nancy Grace Roman, NASA's first chief of astronomy, is often called the mother of the Hubble Space Telescope as its direct successor. Once operational, it will use its thermal optics to investigate exoplanets, planet-forming disks, red dwarfs, brown dwarfs, and other unseen objects.
It's also going to observe distant galaxies to measure the universe's expansion rate, the Hubble constant, which we've talked about before. The hope is that it will shed light on some of the most pressing mysteries in astronomy and cosmology, including dark matter, dark energy, and the Hubble tension. Truly a telescope poised to redefine our understanding of the cosmos.
And that brings us to the end of another fascinating episode of Astronomy Daily. What a journey through the cosmos we've had today.
Absolutely, Anna. From NASA's ambitious plans to build a nuclear reactor on the moon and the strategic race with China, to unraveling the true age of Earth's ancient Moralaga impact crater.
And let's not forget the exciting discovery of Kepler 725c, a potentially habitable super-Earth found using that innovative transit timing variation method. It really boosts our search for Earth 2.0.
And of course, the progress on the Nancy Grace Roman Space Telescope, with its crucial sun shields getting installed, preparing it to peer into the infrared universe and help solve mysteries like dark matter and dark energy.
It's been an incredible day of space news, and we hope you enjoyed joining us for all the updates. Thank you for tuning in to Astronomy Daily.
We love sharing these cosmic stories with you. Until tomorrow, stay curious and keep looking up.